Alright, this is card 149. We're going to start talking about lines, like slopes and all that stuff. Slopes and equations of lines. So, I guess we'll take a few notes first to review our knowledge of slopes and the equations of lines, right? So let's talk a little bit about slope first. The slope of a line is a rate of change and is represented by m. Okay, and there's a couple of formulas for slope. So let's say that m equals the slope, which we can think of as the vertical change divided by or over the horizontal change, which is also equal to rise over run. Okay? You might have learned it as rise over run or the change in. Let's also put delta y over delta x, which means change in y over the change in x. That's what that triangle means, change in. So the change in y over the change in x, right? So now there's a specific time when we want to use a different type of a slope formula. And that's when a line, and it's not a different type of a slope formula, it's just a different description of it, but it's still the same slope. So when a line passes through the points let's change that, through any 2 points, and we'll call them x1, y1, and x2, y2, the slope is, and this is the formula that we would use, m equals y2 minus y1 divided by x2 minus x1. Alright? So when you're graphing a line, you might just want to think about slope as rise over run or vertical change over the horizontal change, right? But when you're given a problem and you're trying to find the slope of something and you know 2 points, you use this formula. That's when you use this one. Okay? It's got y1 and y2 and x1 and x2. That's how you know you need 2 points, because you need an x1, y1 and an x2, y2. So let's see. On the back, we want to draw 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. 6 different boxes. So I want to divide the top every 2 inches. And obviously the bottom, same thing. And I want to divide the sides just in half. So, in the upper left box, let's put a positive slope. Alright? So, when we have, now I'm just going to, let me just check something real quick. I'm just making a mark 1 inch in because I'm going to use that to draw some axes. Because they don't have to be perfect, but I'd still like to make them pretty straight. And I'm going to do the same thing. I'm going to make little marks at 1 inch in between all the boxes so I can make my X and Y axis. Alright, so I just want to do one here and one here. Don't think I'm going to do any on the bottom. In the bottom two, we're probably going to do something different. So for now, we just need that's probably a little too high. Okay, so we're going to do positive slope, negative slope, a slope of 0, and no slope, also known as undefined. Okay, so and I'm going to do the slopes in pen. So a positive slope goes like that, right? It goes from bottom left to top right, as long as it's aimed in that upwards direction. Okay, a negative slope goes the other way. Right, goes from top left to bottom right. A slope of 0 is a flat line. Okay. An undefined slope is a vertical line. Like that. Now in the other two boxes, let me see, let's say the slopes of parallel lines are equal. Okay? So if I was going to draw two parallel lines really quickly, and I'll make a little note here and I'll say same slope. The slopes of perpendicular lines are negative reciprocals, which means they multiply together to get -1. So over on these two parallel lines, I'm going to write like m equals 2, m equals 2. Now if I'm going to draw two perpendicular lines, which would be at 90-degree angles to each other, right? So if I draw one box in there, it means that all four of those boxes are there. I hope that you realize that. So, for example, this slope could be 2, and then this one would have to be -1/2. And the reason is because those two numbers multiply to give me -1, and they're negative reciprocals, right? If I take 2 and I change its sign and I flip it, right? If I make this a fraction 2/1 and I flip that, I would get 1/2. And if I change the sign from positive, it would become negative. So that's what negative reciprocals means. And if you multiply together negative reciprocals, you get -1. All right? So we can show maybe down here that 2 times -1/2 equals -1. Right? Okay. So there's your first card about lines. Just a review of really just slope. So let's put that aside. Let's go to card 150. Alright, and let's see what we want to put on this card. Okay. So first let's write down equation of a line. And there's a few different types, but the one that you really need to know, the only one you really need to know, is slope intercept form. And this is the one that you know anyway, so don't worry about the name. Just know the equation, which is y equals mx plus b, right? Where m is the slope and b is the y intercept, which means where the, how about let's make this a little bit more specific. The y coordinate of the point where the line crosses the y axis. Okay? Oh, by the way, this is card 150. So now horizontal lines are of the form y equals some number. Okay, and for example, y equals 3. vertical lines are of the form x equals some number. For example, x equals -2. Okay? Now, let's see. I guess we should do 3 examples on the back. So, here's how we'll break this up. Let's break the top up again into 3 sections. And let's break the side up into... actually, we don't have to break the side up at all. We're just going to connect those 3, make 3 boxes. So, let's see. Now I want to make a small coordinate axis for each one of these. So I'm going to put a little dot 1 inch in. And now I only want to go down 2 inches. So let's see. Actually, I want to make a mark at 1 inch on both sides. Now I can draw my horizontal axis. My 3 horizontal axes. Now, I need to be able to line up okay. And I'll just make these, something like that. Alright, so I have three axes for 3 examples. Okay? The first one we'll do just a typical line, like y equals 2x plus 1, right? So let's say that this is 1, two, and this will be 1, 2. So this line starts at, and then wait, we need to go up 1 more. 3. This line starts at 1 on the y-axis because that's the y-intercept, right? And my slope is 2, so that means I go up 2 and to the right 1. So from here I go up 2 and to the right 1. So if this is something that you don't know how to do, using the slope and y-intercept, then you better stay after for extra help, because you need to know how to do this very well by this point, so I need to go over it with you. Alright, but that's just one example, right? So if you wanted to write down, my m is 2 over 1, which means up 2 and to the right 1. Okay? Because remember, positive is up, negative is down. And positive means to the right, and negative means to the left. So maybe you want to keep those in mind. Alright? That's how you know. So since I had a positive 2, I went up 2, and I had a positive 1, I went to the right 1. So I went from the y-intercept of B, I went up 2 and to the right 1. B is the y-int. Alright? So now if we want to do an example of a horizontal line, right? It's y equals some number. And let's do, for example, y equals 2. So all you have is a horizontal line that goes through 2 on the y-axis. Okay? Y equals 2. Now let's do an example here. Let's say it goes through negative 2 and it's a vertical line. This one would be x equals negative 2. It has no slope, or it's an undefined slope. And for this one, slope is 0. And that's it, I think. You really don't need any more info than that. You just have to know that, you just have to know it, you have to memorize it, that a y equals some number is a horizontal line and x equals some number is a vertical line. There is really no way around it. Alright? Everywhere on this line, my y value is 2. Everywhere on this line, my x value is negative 2. That's how you can remember it also. So that is card 150. Let's see what's next. Give me 2 seconds. Okay. Alright, in card 151, I want to give an example of one of the typical types of problems that you would be asked. Like, what is the slope of a line? Perpendicular to the line whose equation is 5x plus 3y equals 8. Okay? So let's solve that on the back. We want to know the slope of a line perpendicular to the line whose equation is this. So we want a line that's perpendicular to this line. So we have 5x plus 3y equals 8. So first we want to put it in y equals mx plus b form, right? Alright, so now we have 5x plus 3y. This is the given line. So I'll subtract 5x from both sides. 3y equals negative 5x plus 8. I'm putting this first because that's how my y equals mx plus b looks like. Then I gotta divide everything by 3. And I get y equals negative 5 thirds x plus 8 thirds. Alright? Now I'm going to circle my slope. For a perpendicular line, take the negative reciprocal of the slope, which means flip the fraction and change the sign. So negative 5 thirds becomes 3/5. Alright? And then we want to check. We can erase this number 1 here and just put this in parentheses. Check that the two slopes multiply to negative 1. Negative 5 thirds times 3/5 equals negative 15 over 15 equals negative 1. Okay? So that's an example, a typical problem that you would be given on the Regents exam involving finding the slope of a perpendicular line when you're given the equation of some other line. So I thought it was important to put that one on there. Another one that's really important, let's make this card 152. Let me just find a good problem. Okay. Let me just see this card again. In parentheses down here, let's put find the slope of a perpendicular line given the equation of a line. That's what this one is. For this one, we want to determine whether two lines are parallel, perpendicular, or neither, given their equations. So for example, the lines three y plus 1 equals 6x plus 4, and 2y plus 1 equals x minus 9 are, okay, so that's the problem we're going to solve on the back. So for this card, really, really should have switched this around. So I'm going to do that really fast. You guys are going to hate me for this, but I just want to put it right, just like I did the other one, rather than putting it backwards. So this really should be find the slope of a perpendicular line given the equation of a line. Then I should have example. What is the slope of a line? Perpendicular to the line whose equation is five x plus 3y equals 8. Okay, that's proper. Now we'll go back to this. So we have what we're trying to do and then the exact problem. Let's on the back solve it. Okay, so we're given two equations and neither of them are in y equals mx plus b form. So that's the first thing we're going to do. So I have 3y plus 1 equals 6x plus 4. So I'm going to subtract 1. Now I have 3y equals 6x plus 3. I'm going to divide by 3. Y equals 2x plus 1. So my slope is 2. For the other line, it's 2y plus 1 equals x minus 9. Subtract 1. 2y equals x minus 10. Divide by 2. Y equals, that's 1/2 x minus 5. So my m is 1/2. So since the slopes are not equal, nor negative reciprocals, the two lines are therefore neither parallel nor perpendicular. So they're neither parallel nor perpendicular. If they were both the same, they would be parallel. If they were negative reciprocals, they would be perpendicular. They are reciprocals, right? But they're not negative reciprocals, right? So let's put in a note. They are reciprocals, comma, but not negative reciprocals. Okay, that's another type of problem. Let's look at 153, which is another one of the famous problems that they give you. Let me just find a good one. Okay. So this would be find the equation of a line given a point on the line and the equation of a line perpendicular to the given line. Okay, so here's our example. Let me find a good one. Okay. Find an equation of the line passing through the point six comma 5 and perpendicular to the line whose equation is 2y plus 3x equals 6. Okay, so we start on the back with 2y plus 3x equals 6. And if we're going to make this line perpendicular to this one, then we have to find the slope of it, because we got to use the negative reciprocal of the slope of this line in the new one that we want. So I got to put in y equals mx plus b form. So subtract 3x. I got 2y equals negative 3x plus 6. Divide by 2. Y equals negative 3 halves x plus 3. Okay? So my m is negative 3 halves. The negative reciprocal of negative 3 halves is 2/3. So I want to plug in the given point 6 comma 5 and my perpendicular slope into y equals mx plus b and solve for b. So y equals mx plus b. Here's my x and here's my y. So 5 equals 2/3 times x is 6 plus b. So 5 equals 12/3 plus b. 5 equals 4 plus b. Subtract 4. b equals 1. So now write the equation of the perpendicular line using the perpendicular slope and b in y equals mx plus b. So y equals mx plus b. Finally, y equals, my m is 2/3. 2/3 x plus 1 is my b. Okay? There's probably about, you're almost guaranteed to have one of these on the test, so you better know how to do this. There's probably been about 30 in the past 3 or 4 years that have been given on Regents exams. So you're almost guaranteed to get one of these. That's 153. Now we're going to do a similar problem, which is going to be 154. This one is find the equation of a line given a point on the line. So it sounds the same so far. Given a point on the line and the equation of a line now here's the difference. Parallel to the desired line, or parallel, let's put parallel to the given line. So if we go back to this one, let's underline perpendicular because that's the only difference. And really I should have used my symbol for parallel. Let me see here. Okay. So let me find a problem. This is GG65. Alright. Again, this is one of those where you're almost guaranteed to get one of these on the test. What is the equation of a line? Oop. That passes through the point passes through the point -3 comma -11 and is parallel to the line whose equation is (2x minus y equals 4). So we follow the same process for this problem. Alright, we start with the equation 2x minus y equals 4, and if we want a parallel line to that, we need to know the slope of this line because the slopes of parallel lines are equal. So we have to put this in y equals mx plus b form. So that's what I'm going to do first. Negative y equals negative 2x plus 4. Divide everything by negative 1. Y equals 2x minus 4. So my m is 2. And parallel lines have the same slope, so m equals 2. Okay, that's fine. Now, same deal here. Plug in the given point, which in our case is negative 3, negative 11. And the slope into y equals mx plus b, and solve for b. So y equals mx plus b. Y is negative 11, m is 2, x is negative 3. So negative 11 equals negative 6 plus b. Add 6. B equals negative 5. Now finally, write the equation of the parallel line using the slope and b in y equals mx plus b. So we have y equals mx plus b. Our final answer is y equals m is 2, x, and then b is minus 5. So instead of plus negative 5, right, we'll just put minus 5. There you go. And like I said again, you're almost guaranteed to get one of these on the Regents exam. There's been about 30 in the past for this type of problem also. Okay? Let's look at, I think there's one more. Yes, one more type of line. One more type of problem that we have to go over. So 155 is find the equation of a line that is the perpendicular bisector of a line segment given the endpoints of the line segment. Alright, and as an example of this type of problem, I need to just find one real quick. Okay. Example. Which equation represents the perpendicular bisector of segment AB whose endpoints are, let's say A is 8 comma 2 and B is 0 comma 6. Okay? That's what we need to find. So How do we do that? Well, we got to find the equation of, or we got to find the slope of line segment AB, right? Because if we're finding a perpendicular bisector of line segment AB, then it's going to be the negative reciprocal of the slope of AB. All right? So that's what we're going to do. All right? And then we're also going to have to find the midpoint, because we need to, I'll show you, you'll see why as we do the problem, because in order to find B, we got to use a point on the line, and the only point we're going to know that's going to be on this perpendicular line is the point directly in the middle of A and B. Okay? So, as a matter of fact, we're going to put this one aside for now, and we're going to talk about midpoint and distance, and then we'll come back and do this one. Okay, so put 155 aside, and let's now go on to 156. All right, so let's talk about midpoint first. The point halfway between the endpoints of a line segment is called the midpoint. A midpoint divides a line segment into two equal segments. Actually, two congruent segments. So to find the midpoint of a line segment, when you know the coordinates of its endpoints, use, and the formula that we use for this is x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. Okay? And then, let's see, I think there's another type of formula I can give you. If you know the coordinates of one endpoint and the midpoint, comma, use x midpoint, or xm, equals x1 plus x2 over 2 and ym equals y1 plus y2 over 2. Yikes. That should be written clearer. Okay, and remember that xm is the x coordinate of midpoint, and ym, whoops, okay, and you'll see how to use both of those right now. On the back, let's split this up into halves. All right, let me find a good problem. Let's see. Okay. Example 1. Line segment AB has endpoints. A is 2, -3, and B is -4, 6. What are the coordinates of the midpoint of segment AB? So I use that first formula. I use x1 plus x2 over 2, comma, y1 plus y2 over 2. All right? So I'll do 2 plus -4 over 2, comma, -3 plus 6 over 2. Right? That's my x1, y1, x2, y2. So I get -2 over 2, comma, 3 over 2. So I get finally -1, comma, 3 halves. Okay. Now let's look at another example. Let's see if I can find a good one. Okay. Segment AB is the diameter of circle M. The coordinates of A are -4, comma, 3. the coordinates of M are 1, 5. What are the coordinates of B? So first we can draw a quick picture. M, A, and B, right? We know A, negative 4, 3, and we know M is 1, 5. So we're trying to find B. Let's call it x2, y2. So we got to use the one where we know an endpoint and a midpoint. So first we'll say xm equals x1 plus x2 over 2. The x-coordinate of the midpoint is 1. X1 is negative 4. What we don't know is x2, right? Now we can cross multiply. And we get x2 is 6. Now we're going to do ym equals y1 plus y2 over 2. The y-coordinate is 5 equals y1 is 3 plus y2 over 2. If I cross multiply, I get 10 equals 3 plus y2. Subtract 3. I get y2 is 7. So B is 6, 7. Okay? Now, that we know the midpoint, let's go back to this problem. Which equation represents the perpendicular bisector of segment AB, whose endpoints are A, 8, 2, and B, 0, 6? So first let's draw a picture. Alright, we have this segment. A, B, and we know A is 8, 2, and B is 0, 6. Right? And we want to find the equation of the perpendicular bisector. Okay? So, what else are we given? That's it. Okay? So first, let's find the slope of this segment, right? M equals y2 minus y1 over x2 minus x1. M equals 6 minus 2 over 0 minus 8. So that's 4 over negative 8. So that's negative 1/2. Actually, hang on. Let's not box that out. Let's put an arrow and say the negative reciprocal is m equals positive 2 over 1, which is just 2, right? We flip it and we change the sign because we want a perpendicular line. Okay? Now, so we know the slope of this line. It's 2. The problem is we don't know the y-intercept of it. All right. So to find that, we need a point on the line to plug in to y equals mx plus b along with the slope. But we don't have a point on that line. All right, but we can find one because it's the midpoint. Let's call it m. So to find m, we're going to do the midpoint formula. It's 4, 4. All right. Now we can use this point and the perpendicular slope to find b. So we have y equals mx plus b. 4 equals 2 times 4 plus b. 4 equals 8 plus b. Subtract 8. And we get b is negative 4. And that's an important value for us. Okay? So now, use the perpendicular slope and b to write the equation. Y equals 2x, m is 2, right? Instead of plus 4, it's minus 4. Okay? That's how you do it. So that one was 155, and this one we did before with the midpoint was 156. So now let's do 157. Let me just sharpen one of these, if I have a sharpener around. Which I don't, so we're not going to sharpen it. 157. Alright. 157 is the distance formula. So let me just pull that up. Okay. To find the length of a line segment, or the distance between two points. Yikes. When you know the coordinates of the endpoints. Use the distance formula, which is distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay? Let's see now. All right, let's do an example of that. Okay. If the endpoints of AB are A is negative 4, 5, and B is 2, negative 5, what is the length of segment AB? Okay, so square root x2 minus x1 squared plus y2 minus y1 squared will be the square root of x2 is 2 minus x1 is negative 4 squared plus y2 is negative 5 minus y1 is 5, like that, which gives us 2 minus negative 4 is 2 plus 4, and 2 plus 4 is 6, so we have 6 squared plus negative 5 minus 5 is negative 10 squared. That gives us 36 plus, when you have a negative 10 inside parentheses squared, that's positive 100. So we have the square root of 136. Right? So we're going to take 136 and we're going to factor it. And the factors could be 2, and that would break that into 136 divided by 2. That's 50, 65, 66, 68. 2 and 68. 2 is prime, so I circle it. Now let me keep going. Another 2, and I would have 34. Let me keep going. 2 and 17. Now I have all primes. So the square root of 136 is actually 2 times 2 times 2 times 17. Every time something appears twice, I cross them both out and bring one of them out front. So I have 2 radical 2 times 17. I just multiply what's left back underneath the radical together, so it's 2 radical 34. Okay? So that is an example of the distance formula.